So sample problem 17.2 kind of walked us through the idea that when we sum up individual reactions, we need to multiply the equilibrium constants. And what the next sample problem is going to do is remind us that sometimes when we're summing up individual reactions, we might need to scale up or scale down reaction coefficients so that terms cancel, or we might actually need to reverse a reaction. So we need to remember the rules for what we do. And so if we are flipping a reaction, what that means is we're taking 1 over the equilibrium constant. If we're going to scale up or down, so if we're going to scale a reaction, then whatever that scaling factor is becomes an exponent. So we're going to scale up or down by that coefficient. So we'll see this applied as we kind of work through these sample problems here. So here's our reference equation. N2 plus 3H2 gives us 2NH3. So let's see if we can figure out what's going on in the first reaction. Well, we still have N2 and H2 as reactants and ammonia as a product. So we're not doing anything where we're flipping the reaction. But what we can see is that we're scaling the coefficients. We've scaled the reaction by 1/3. And note it's important that we scale all of the reaction coefficients by the same parameter. Otherwise, we're not maintaining the equality of that equation and it will no longer be balanced. So what this means is this scaling factor now needs to become an exponent in scaling the equilibrium constant. So what we can say is that Kc for this A reaction is going to be Kc for the reference reaction to the 1/3 power. Remember, taking something to the 1/3 power really is the cube root of that. So make sure you're comfortable doing this in your calculator. 2.4 times 10 to the minus third. Take the cube root of that, and that equals 0.13. Let's take a look at the second problem here. In the second problem, we can see now ammonia is a reactant, and N2 and H2 gases are products. So we've flipped the reaction. So we need to reverse the reaction. But in addition to reversing the reaction, we've also scaled it down by half. So we scaled the reaction by 1/2. So two things have to happen here. Reversing the reaction means we take 1 over the reference equilibrium constant. Having a coefficient of 1/2 means we have to take Kc of the reference and take the square root of it. But we have to make sure we actually do this for the entirety. So Kc for the new B reaction is 1 over Kc for the reference, and we have to take the square root of that. Do this mathematically in your calculator, and you'll end up with 20. Again, an important skill to practice as you work through these sample problems is not just making sure that you understand how to actually do the problem, but make sure that you can get the correct answer in your calculator.